Hello, welcome to this video on interval and set builder notation. This will be a lesson on this topic. Okay, let's go ahead and take a look at our objectives here for this lesson. So the first thing is we want to go ahead and define interval notation, and then we're going to go ahead and define set builder notation, and then we're going to look how to write inequalities as interval notations, and then we're going to use graphs to write interval notations. And then we're going to use set builder notation to express sets. So a lot of little very specific objectives here. You know, the word sets and notation and intervals and things come up, but we'll get into that here in a second. But one of the things I want to stress is that this is really important. This particular topic is very important when we're trying to describe the behavior of certain functions in mathematics, okay? Especially the range and their domain. So although this might seem a little maybe not as important as other things, it's actually very important to be able to express sets in a proper way. All right, so it's not too difficult as well. Let's get into this. Okay, interval notation. Excuse me. So first of all, we use this word interval, all right? So what is an interval? Well, this is basically an interval right here in mathematics, okay? It's just some part of a real number line, okay? So, for example, we're going, in this particular graph is saying all the numbers that are greater than -2, okay, that go all the way up to 10, including 10. So if this particular graph doesn't make sense to you, then you might want to go back and review your basic algebra, okay? So remember, the open circle is saying it starts right after -2 or above -2, okay? All the numbers that are greater than -2 but are not equal to -2. So we would express that this way, right? Using the kind of basic inequality expression. And then all these numbers here go all the way up to 10 and include 10. So we can say this, all right? So if I'm trying to express this interval, and an interval is just kind of a piece of the real number line, this is one way I can do this, all right? Now, interval notation, this is kind of more of a longer way to write this. Interval notation is kind of a shortcut way of doing it. So the way what we're going to do is every time we have an open circle, okay, we're going to use parentheses, okay, either this one or this one, and closed circles, all right, we're going to use brackets, all right. So interval notations, it's basically more difficult than expressing this same interval this way, all right. So we're starting at -2, comma, we're going to 10, bracket, and that's it, okay. Now there is a few other things that we're going to get into here in a second about infinity and everything else, but those are not too difficult. But this is just the basic essence of what interval notation is, right? So we can write this part of the real number line this way, okay? This is graphically seeing it. This is using inequalities, and this is using interval notation. And interval notation, probably the most common way we're going to see things written, especially at the pre-calculus level and beyond. All right, so let's take a look at set builder notation. Now, set builder notation, this is obviously another way to express intervals, okay? And sets, all right? So obviously here we got the word set. So a set, if you recall, all right, is just a collection of items, okay? So it's kind of like a team, all right? So if I have a collection of items, A, B, C, D, all right, all these guys are called the elements of this set, and then these brackets indicate that this is a set. And we can give sets names, okay? So I could say, well, I'm going to refer to this as set A, all right? So I can say this, or I could even say set A, okay? And this would represent all these guys here, okay? And these are the elements of these sets. Now, so that's basic set notation. Once again, this should be review. Now, here, set builder notation is where we're specifically describing the characteristics of what's in the set, the elements of the set. Okay, so in this example, okay, um, here is the set name. Okay, so I'm going to call this set n. Actually, let me back up here. I'm kind of getting ahead of myself. All right, so set bundle notation, it goes this way. You're going to have these brackets like this, okay, and then we're going to go ahead and just establish a variable x, and x just represents a kind of general description of the elements that are going to be in the set, okay. So you're going to put this little vertical line, okay, and then you're going to talk about the property of what those elements have in the set, okay. So let's kind of take a look here at an example. All right, so let's say I have set n, okay, and set n happens to be the collection or the set of all numbers x, okay, such that x, okay, these numbers is a positive integer or positive integers. Now, that would look this way, okay? That would be all the numbers x such that x, or these numbers, are positive integers. So I can just start writing out the positive integers. So 1, 2, 3, 4, etc., right? On and on and on. So that would be that set, okay? That's also set n. Now, where these are the elements of that set. But set bundle notation is written in this way. Kind of, this is really seen at kind of even more advanced level mathematics. This becomes very, very important. But you will come across it at this level of math as well. So, you know, the purpose of this lesson is just to get you familiar with these various different notations. Okay. And of course, we're going to be doing a lot of examples of this. Okay, now this I'm going to ask you to write down, all right? So I kind of pause this here for a second. I don't know if I can fit this all on the screen at once. So go ahead and write this little chart. There's going to be some more rows here, and we're just going to be talking about what you would see graphically in terms of an interval, and then how we would express this using set builder notation and interval notation over here. Okay, so I'll give you a moment here so you can start writing this, and then I'll scroll down here in a second. Okay, once again, too, you could put the video on pause. Okay, this is going to make a lot more sense when I start doing examples, especially with infinity here. But you do want to have this as a reference, cross-reference. Okay, here, and this is the rest of the chart. All right, let's quickly take a look at the chart and see what this says. So like I said here I have an open interval graph, okay, where these are the numbers that are between A and B, but not at A and B. So I could write it this way, right? All the numbers x such that they're greater than A and less than B. So this set would be all the numbers such that, all the numbers x such that x is greater than A and less than B. So that would be set builder notation. And then here's an example of interval notation, all right? So you can see how these all play out. Now, what I want to get down to is these graphs here that involve infinity, okay? So this graph here indicates all the numbers that are less than b. All the numbers are less than b, but not including b. So this is set builder notation, all the numbers x, such that x, these x numbers are less than b. Now here, in interval notation, we have this negative infinity, okay? So anytime you're heading to the left direction of the real number line, this is negative infinity, okay? And then over here, I'm going to go into the next example. This is positive infinity or just infinity, okay? So, and by the way, too, every time you include infinity in your interval notation, you will have the open parentheses because it can never be equal to infinity, okay? So it's going to be open bracket, or excuse me, open parentheses, negative infinity, comma, to b, okay? And once again, these when we do examples, this will make a lot more sense. So here, in this next part of this chart, we have all the numbers that are greater than a, including a. Okay, now they're heading in a positive direction towards positive infinity. So set builder notation, all the numbers x such that x is greater than or equal to a. Okay, and here we're starting at a, so that's going to be a bracket, and that says a is included. Okay, and it's going to infinity or positive infinity. Okay, and then all the real numbers here are going to be going from, this is the entire set of real numbers, are going from negative infinity to positive infinity. Okay, so I'd have open parentheses on both. Okay, and trust me, the notation here might look a little bit complicated, but it's not that difficult. Okay, let's take a look at some examples here. So let's write this inequality using interval notation. Now, one way to kind of do this, until you get the kind of hang of it, and you may not need to do this, is just think of a number line, okay? So if I was to put this on a number line, this is all numbers that are greater than 6, okay? So I would have 6 here, okay, and it would be going this direction, right? Okay, and this would be an open circle because it's not including 6. So here, I would be like, oh, okay, for the interval notation, it would be open bracket, 6, comma, positive infinity, another, it's not an open bracket, excuse me, parentheses, okay, because this is going towards positive infinity. All right? No more difficult than that. Of course, now if I had this as greater than or equal to, okay, this would be closed, and now this would be bracket 6, comma, positive infinity. Now, of course, we're going to be doing a lot more of these problems and example sets, but it's really, I don't want to make it any more difficult than it has to be. Just you have to get used to this. Now, you don't necessarily have to write the graph, but it's good to be able to do that. It's going to give you another one here. How about, I'm just going to make this up. Let's see if you could do this without the graph, okay? All the numbers that are greater than or equal to -2, but are less than 10. Okay, so here I'm going to write the -2, okay, and then I got 10, right? So 10, it's not, well, let's start with the -2. The -2, okay, it's equal to, so if I say that equal to, it's going to be bracket, okay? And for 10, it's not equal to 10. It just goes up to the numbers not including 10. That's so that'd be an open parenthesis. All right, not too difficult. All right, so using graphs to write interval notations, basically just another way to kind of reverse engineer what we've been doing. So why don't you go ahead and see if you can write the interval notation for this first graph, okay? So I'm not going to tell you what this means. You should know this is basic algebra 1 when you're working with inequalities. So by the way, too, if you're not quite sure about these particular graphs and you want to go back and review your algebra. All right, so this first one is what? It's saying all the numbers that are greater than 3, including 3. So this is going to be a bracket 3, comma, and they're all going to go heading towards positive infinity. Positive infinity, parenthesis. Okay? All right, so the next one is what? What is this saying? So these are all the numbers that are greater than -11, but not including -11, all the way up to 4, but not including 4. So this is going to be parentheses -11, comma, 4, parentheses. All right, let's go ahead and move on. Like I said, not difficult. Okay, so let's use set builder notation to express these sets. And there's kind of different ways you can do this, but let's go and start with this first one, okay? So this set, let's call this set A. Let's give it a name, okay? So what does this look like to you? What traits, what characteristics are going on here, okay? Or what's some way you can describe the elements or the behavior, what's going inside this set? All right, so you might want to say, well, set A is equal to all numbers x such that x is what? They look like they're the positive odd integers, right? Maybe you can abbreviate it this way, positive odd integers. Okay. So this is an example of set builder notation. So I could say, hey, I want you to write out the set such that x, all these numbers x's are going to be positive odd integers. So I can write it out this way or I can write it out this way. And this way is a little bit more descriptive of what's going on. Okay. So how about this next one? All right. Okay, so let's just write it this way. All numbers x such that what? Okay. And it's just basically a kind of a written description of what's going on. All numbers x such that x is greater than, and equal to -6 and less than 3. Okay, nothing more complex than that. All right, let's move on to the next one. All right, so these are all numbers x such that what? Okay, such that x is greater than, greater than or equal to 5. Not difficult. All right, how can we write the rational numbers, okay? Now, if you don't remember what the rational numbers are, then you might want to go back in your algebra days when we're talking about real numbers, but they're part of their specific subset of the real numbers, okay? So the rational numbers are we can define as this way, okay? So Q is the abbreviation for them, okay? So the set Q such that X, okay? Now X would be numbers such that we have A and B, where A and B are elements of the integers, okay? Now this is a little bit more kind of fancier way of doing this. Usually we're going to see this in a more higher order mathematics, but this is another way of kind of doing this. So we have the rational numbers, remember, are numbers that we can express as fractions, okay, where the numerator and denominator are members of the integers, okay? Now there would be another condition actually here. We can also say b cannot be equal to 0, okay, because 0 cannot be in a denominator of a fraction. So this is kind of an example how we would use set builder notation. But once again, for the purposes of this course, my kind of goal here with you is just to get you familiar with this, all right? As you progress in mathematics, you'll need to be having to read about various sets and kind of understand what they're saying to you. So if I wrote out this condition, okay, I wrote out this description of this set, you'd be like, oh, okay, this looks to be the rational numbers, all right? But before we move on, the main kind of notation I'm going to be using is going to be interval notation. So don't be intimidated by this at all. All right, let's move on, okay? All right, so in review, all right, interval and set builder notation, these are both express sets to equations, inequalities, things like function, domain, and range. So these inequalities, things that are greater than or equal to, this is the stuff that we use in obviously straight inequalities. We're talking about the description of a function, domain, and range, etc. So the way we're going to actually describe these various intervals, okay, is using interval notation, right, primarily, right? Now we could use set builder notation, right, because it's a method of describing elements that belong to a given set. So this is a little bit different than interval notation because it's talking about the properties or description of what's inside of those particular sets. Okay, so this comes in handy, especially the more higher order level mathematics, okay, that you get into. All right, so interval notation is a method of describing subsets of the real number line. You can also use interval notation to describe the entire real number line as well. And so intervals occur frequently in math, so interval notation is easy to use to describe these sets, and that's primarily the reason why we're learning this. We could just use straight inequalities, but we're trying to make our life a little bit easier. All right, so like I said, this is not difficult, but like a lot of things that are easy, that could be easy to mess up. So you definitely want to do the example sets. Okay, so keep working hard and we'll see you soon.